Hi everyone! Thanks for tuning in. This is Andrea from Orient. In this video, we're going to show you how to set up a simple neural network using our NNetDesigner software. The first thing we need to do is to select our data source. For this simple neural net, we're going to use the bodyfat.csv database downloaded from Kaggle. You can find the link in the description box. We now see the data, which includes density, percent body fat, age, weight, height, and a number of other features that may be used to predict body mass. You can also look at CSV data files in Excel or your preferred viewer. The body fat database has 252 data points. Next, we're going to draw the neural network. First, we need some input nodes. We will start with 4. Following the inputs, we'll need preprocess nodes to normalize our data. After the preprocess nodes, we'll add 2 layers of 6 hidden nodes each. We can draw the first 6 nodes and then copy and paste the following 6. Finally, we'll add 2 output nodes. Once we have our nodes drawn, we can draw our connections. If we don't want to draw all the connections by hand, we can use the autorouter. First, we select the nodes we want to autoroute, and then select Auto Connect. We then orient the big arrow in the direction we want to forward propagate, and click the mouse. Next, we bring out and pin the Properties menu. This allows us to view and set the properties for each node. We want to connect our input nodes to the data source. For our 4 nodes, we select weight, age, height, and abdomen. For the output nodes, we select density and percent body fat. Next, we open the Edit Process dialog box and select the process node following the weight input node. The upper graph shows a histogram of the age input data, and after clicking the normalization button, the bottom graph shows the normalized data. Notice the new x-axis limits. Neural nets learn best if we normalize inputs and outputs consistently. We now normalize the remaining input nodes. Because activation functions for the output nodes are currently set as sigmoid, which can't really reach 0 nor 1, we are selecting 0.2 to 0.8 for normalization. Before we go any further, we can look at the properties of the hidden nodes. Let's set our selection to nodes and then highlight the nodes we want to look at. Right now, the activation functions for our hidden nodes are all set to sigmoid. If we like, we can select different functions, but for now, let's leave them as sigmoid. Our output nodes are also active and set to sigmoid. Our design is now set, so it's a good idea to save the file. Next, we'll unpin the Properties tab and select and pin the Train Graph tab. We're now ready to train. After selecting the Train tab, it's a good idea to randomize inputs, so we'll verify that selection is made. Then, we'll click on Verify to make sure the net is ready. The Output tab shows that net verification is completed. We can now start training by clicking the gears to train. On the train graph, we see the RMS error versus epoch as the net trains. If we left-click on the graph, we can open the Graph Options dialog and adjust the scale to view the data with better resolution. At any time, we can stop training by clicking Stop and look at the outputs by clicking Output. The net output view shows the neural outputs in parentheses next to their corresponding training data. We now close the net output view window and resume training by clicking the gears again and selecting Continue to let the net train for a while. After running for several hours, we can see by viewing the training error graph that training is pretty much finished, since the error is just about flat. We can stop training and open the output datasheet to view net performance compared to target data. As we can see, the simple net has done a reasonable job of learning, given its size and the limited number of inputs we used. If we want to export the net to code, we can select Export and select Code Type. For our next video, we'll look at how we can improve net training performance. Thanks for watching! We'll see you next time!